All right, and welcome back. So today we're going to be continuing our conversation about how to solve systems of linear equations using the elimination method. Last time we talked about some of the guide notes, and we're going to be going through a couple more examples on how to use the elimination method to help us solve these systems. So without further ado, let's begin. We're going to solve this system. X minus 2y is equal to negative 19, and 5x plus 2y is equal to 1. Let's remember what setup we want when we're using the elimination method. In order to use the elimination method, we want to choose a variable that we want to eliminate, and we have to make sure we have opposite coefficients. So let's say I want to eliminate the x, then it has a coefficient of 4. That means I have to have the other equation have a negative 4x term because 4 and negative 4 are opposite terms. We're dealing with the same variable. So one of the things that I notice here is that x minus 2y is a top equation, 5x plus 2y is a bottom equation. Negative 2 and positive 2 are opposite terms, and they're both dealing with the y. So we already have that. These are already aligned, and we have opposite terms already, so we can just use the elimination method. We can add them together, and we get 6x is equal to negative 18, because negative 2y plus 2y turns into 0. Thus, we just get 6x is equal to negative 18, and we can solve this to get x is equal to negative 3, which is great, but we can't stop here. Hashtag can't stop, won't stop. We have to now plug this x value into one of the equations and find the corresponding y value. When we do that, as you see, and pause it whenever you feel like you need to, you get y is equal to 8. Now that we know y is equal to 8, we write the solution as an ordered pair, negative 3, comma 8. And that's going to be our final answer, negative 3, comma 8. We're looking for the coordinate point, the solution to the system. And again, this one was more straightforward for us because we have opposite terms already. Negative 2y is the opposite of positive 2y, so we add them together and we get 0y. Oi! And then we get 6x is equal to negative 18. In this example, we have the system. Again, feel free to pause whenever you need to. 3x plus 4y is equal to 18, and negative 2x plus 4y is equal to 8. One of the things that I noticed is that I said the same thing twice. I said 4y twice, meaning that 4y is in both of the equations. So we need to add the opposite of each term in the second equation. So when we talk about subtracting and addition, if we are adding something, it's also same as subtracting its opposite. So really what we just did here was we multiplied the bottom equation by negative 1. Notice that we started with negative 2x plus 4y is equal to 8. Let me see if I can highlight that for you. So we started with negative 2x plus 4y is equal to 8. We multiplied by negative 1. So now we end up with positive 2 minus 4y is equal to negative 8. So we really multiplied by negative 1 in that bottom equation because now we have opposite terms, positive 4y in the top equation and negative 4y in the bottom. And now we can eliminate y, and we get that x is equal to 2. And likewise, as we always do, once we find the value of one variable, we can't stop. Hashtag can't stop, won't stop. And we have to figure out the y, or we have to figure out the opposite variable because we just found the x. So now we have to find our y. We go back and we substitute x in. Again, feel free to pause whenever you need to. We solve for y. We get y is equal to 3. But again, we are not done here. We have y is equal to 3. That's great. X is equal to 2. That's great. Final answer. We have to write our final answer. I'm going to write out as an ordered pair. We find that the final answer is 2, 3. Therefore, our final solution to the system is 2, 3. Again, what we did is we multiplied by negative 1 on the bottom equation to every single term because we want to keep everything balanced. You can technically think about it as adding the opposite of each term, but I like to think of it as we are multiplying by negative 1. So you know what? I'm going to change this. No me gusta. Multiply by -1. Cool. Sweet. Let's go through one more example. In this system, we have 7x minus 12y is equal to -22, negative Taylor Swift. 5x minus 8y is equal to -14. So one of the things that I notice is that we do not have any opposite terms. We don't even have any similar terms. Where in the previous example, we had the same exact term in both equations. In here, we don't have any of that. We don't have any similar terms. We don't have any opposite terms. So what we need to do is we need to multiply both equations by some values. And we have to choose a variable that we're going to eliminate. We're going to eliminate the y. We're going to eliminate the y. And if we multiply the first equation by 2 and the second equation by -3, what that's going to do is, since we're trying to eliminate, oh, it's still on the pen. Goodness golly, Miss Molly. Yes, I want the eraser. Merp. All right. Since we have -12y and -8y, if we wanted to eliminate the y variable, and you can eliminate the x variable, that's totally fine. But in this case, we want to eliminate the y variable. If we multiply 2 and -12, we get -24. So we have to get the opposite of that in the other equation. So we multiply -3 by -8 and we get +24. That then creates the opposite terms. Again, as we just said, -24 and +24. What we're using essentially is a distributive property. We have to make sure we distribute to each term. Just like before, when we had to isolate for a variable, we had to divide by each term. We have to distribute 2 to each term, -3 to each term. We have to stay balanced. We have to stay equal. So we multiply to each term. And now we're going to be able to eliminate y, and we get that x is equal to 2. And now, just like before, and every other way that we have been working with elimination and with substitution too, once we find one variable, we have to go plug it in and find the opposite variable. So we use one of the original equations, and we eventually find that y is equal to 3. Therefore, our final answer is 2, 3. And in this example, we had to multiply both equations to generate those opposite terms. Great job today, folks. If you have any questions, please jot them below. You're doing a really good job. I'm really proud of you. Keep up the good work, and I will talk to you soon.